Dear students, if I ask you to give me 1 kg of salt, you can easily give it to me because kg is an everyday unit. But if I ask you to give me 1 mole of salt, many of you can't give it to me because mole is not an everyday unit. See, this is the picture of 1 kg of salt or 1000 grams of salt, and this is the picture of 1 mole of salt. There is 58.5 grams of salt here. Have you noticed that the gram units have been used in both the pictures? What is the reason behind it? Because gram is the unit of mole. Now the question is, how did we get 1 mole of salt equals to 58.5 grams? The reason is 1 mole of any substance is equal to molecular mass in gram units of that substance. Now, how we can determine the molecular mass of any substance? Molecular mass can be determined from the molecular formula of that substance. From the molecular formula of the substance, we will find out how many atoms are there in that formula. Then we will add their atomic mass. The total amount of the atomic masses will be its molecular mass. Then we will just express the molecular mass in gram units. This value of molecular mass in gram units will be the value of 1 mole. Let us try to understand through examples. We can take the substance salt as an example. So, what is the molecular formula of salt? NaCl. How many atoms are there in this molecular formula? 2 atoms. One is Na and the other is Cl. The atomic mass of Na is 23. The atomic mass of Cl is 35.5. If we add these atomic masses, we will get the molecular mass of NaCl. Therefore, the molecular mass of NaCl is 23 plus 35.5, and that is 58.5. Now we will express this molecular mass in gram units. That is 58.5 grams. This 58.5 grams is equals to 1 mole of NaCl. So finally, we get 1 mole of NaCl is 58.5 grams. Let us think the example of a liquid. See, this is the picture of 1 kg of water or 1000 grams of water. And this is the picture of 1 mole of water. There is 18 grams of water here. So our new substance is water here. Water has the molecular formula H2O. There are 2 atoms here in this formula. One is hydrogen and the other is oxygen. But there are 2 hydrogens here. Atomic mass of one hydrogen is 1 and atomic mass of 2 hydrogen is 2 into 1, that is 2. Atomic mass of oxygen is 16, so molecular mass of H2O will be 2 plus 16, that is 18. Now we will express the molecular mass of H2O in gram units, that is 18 grams. We have already learned that 1 mole of any substance is equals molecular mass in gram units of that substance. Therefore, 1 mole of H2O is equal to 18 grams. Since we have already learned how to determine 1 mole of any substance, therefore we can also determine 2 moles, 3 moles or whatever moles of any substance. If there is no number before any molecular formula of any substance, then it will be 1 mole. And if you get any number before the molecular formula of any substance, then that number will be the mole number of that substance. For example, see, there is no number before the formula of water. So we can say that there is 1 mole of water here. Again, see, there is the number 2 here before the molecular formula of water. So we can say that there are 2 moles of water here. Now, question is how we can measure 2 moles of any substance? We will just multiply 2 with the molecular mass in gram units of that substance. A little earlier we got 1 mole of water equals 18 grams. Therefore, 2 moles of water will be 18 into 2, that is 36 grams. Now we will learn the relation between mole and Avogadro's number. Number of molecule is really large because each molecule is very tiny. Actually, it is impossible for us to count this number. We can just estimate it. Now question is how can we estimate the number of molecules present in 1 mole, 2 moles or 3 moles sample? Avogadro has given us a number to get rid of this problem, which is known as the Avogadro number, and that is 1 mole is equivalent to 6.022 into 10 to the power 23 molecules. In some textbooks, we might find it as 6.023 into 10 to the power 23. So, can you tell me how many molecules are present in 1 mole of salt? Yes, it is 6.022 into 10 to the power 23 molecules. You should also remember that mole is often written as mol in short. For gas, to measure a gas, we only use mass and volume of the gas. Because estimating of gas molecules is impossible. So what is the volume occupied by 1 mole of a gas substance? 1 mole of any gas occupies 22.4 liters at STP. STP stands for standard temperature and pressure. Standard temperature means the temperature is 0 degree centigrade. That means the room temperature will be freezing cold. And standard pressure means 1 atmospheric pressure. That means the normal pressure we feel on the surface of the earth. But remember, this works only for gases. If you like this video, do not forget to subscribe to the channel and hit on the bell icon, so you are always updated whenever I publish any new video. You do not miss any of them.